All right, this is the last help video for Unit 1, Probability Distributions. We're going to just go through a bunch of practice problems from this unit, just so you guys have something to study before you move on to your Unit 1 test. So, as you guys know, I like to use the cubes, problem-solving strategy, so it's on the right here. When doing word problems, I'm going to model that in my videos. Feel free to do the same. But let's go ahead and get started. Suppose that the weight of 5,400 registered female Labrador retrievers in the United States are distributed normally with a mean of 62.5 pounds and a standard deviation of 2.5 pounds. Approximately how many Labrador retrievers weigh less than 62.5 pounds? Online, you're going to have to, of course, enter your answer in the box. But let's go ahead and circle our numbers. So that's step 1. So I'm going to put my pen here. I have 5,400. I have 62.5 and 2.5. I also have 62.5 here. So first part of my cubes is done. Next thing, we need to underline the question. As you guys know, you can always look for that question mark. I always look for the phrases, how many, find, what, but this here is our question. We are looking for how many lab retrievers weigh less than 62.5 pounds. Now we're going to box the words, the key words. And so labels are always boxed, so we're working with pounds here. We are also going to box up distributed normally. So that means we can use our z-score formula, which I'm going to put in here. And last but not least, we always kind of want to look at that phrase here. We have less than. So that means we are looking to the less or the left side. So now let's go ahead and cross off or eliminate all of the things that we don't need. So bye words, see you later. Favorite part here. Oh, I should have probably boxed up mean and standard deviation. So I'm actually going to do that real quick. Mean, standard deviation. Don't want to cross that off. Okay. So now let's go ahead and identify what we are given. What is our raw score? Well, that is what the data point that we are given here. So our data point is 62.5. Our mean is also 62.5. Our standard deviation is 2.5. And so let's go ahead and plug that into our formula. So I have 62.5 minus 62.5 divided by, remember that means divide, 2.5. Well, when I plug that into my calculator, some of you can do this in our heads, right? We get 0 on the top and 2.5 on the bottom. When we divide that out, we get 0. So now remember, we're looking for that probability, right? So our mean here is 62.5. If we're looking at less than, that means it's on the left. And this area under the curve, because our z-score is 0 or smack dab in the middle, 50% or exactly half of the Labrador Retrievers weigh less than 62.5. And so if we divided that by 2, that would be 2,700 Lab Retrievers. All right, so for our next example, we actually have to label a normal curve based on the given information. And now the height of a 16-year-old boy in the United States is normally distributed with the mean of, I'm going to circle my numbers here, 68.3 inches and a standard deviation of 2.9 inches. What percent of the 16-year-old boys are between our 62.5 and 71.2 inches tall? And of course, we're going to have to convert it to a percent. Now I circled my numbers. I'm going to underline my question. We're looking for that keyword what. Whatever comes after it is what we're looking for. I'm going to box up my keywords here in red. So standard deviation is something that we need. We need our mean. We're going to label our normal curve. Okay, that's going to help us identify what pieces go where. And last but not least, all of our labels need to be. So we're focused on inches and percent. All right, let's eliminate everything else. All right, let's get after it. So to start, to label our curve, we have to remember that our mean is always that center line. So we're given our mean, which is 68.3. So I'm going to go ahead and start with that. So 68.3. Now, from there, we know that our standard deviation is 2.9. And so that means to the right here, we're going to add 2.9 to each number to get our label. On the left, we're going to subtract 2.9. So let's start with adding here. 68.3 plus 2.9. Of course, use your calculator, but I am going to get 71.2. Add 2.9 again. I get 74.1. Add 2.9 again. I get 77. On the other side here, I'm going to write that in green. I'm going to subtract 2.9 and I get 65.4, 62.5, and 59.6. Now, looking at the problem here, we need to figure out how many boys are between 62.5 and 71.2. And now I'm going to use my highlighting tool here, and I'm going to highlight where that's located, or the area that's located under our curve. So I see 62.5 here, and I'm going to keep highlighting until 71.2. So now to answer this question, we actually have to use our normal distribution little image here. That will actually help us figure out the percent. And now I'm going to use my highlighting tool again. So if you notice, these are the 3 categories that this range takes up. So it's these 2 categories in this category. Now, in order to find the percentage, we're going to just add these three up. So we're going to take 34% plus 34% plus 13.5%. And when you add that up, you get 81.5%. All right, the next problem we are going to go through is this one right here. As I read through it, once again, I'm going to be circling my key information, boxing up my keywords, identifying my question, and of course, eliminating any other words that do not matter. The scores on a standardized test are normally distributed with a mean of 500 and a standard deviation of 100. Sophia scored 632 on the test. What percent, so we're looking for percent, of the students scored below Sophia? Now, make sure you read directions carefully so we don't get it wrong. Round the answer to the nearest tenth. All right. So for this one, we first need to calculate our z-score. Let me go ahead and identify what all is given. So we're given 632, which is our raw score. We're given a mean of 500. And we're given a standard deviation of 100. So using that, we're going to go ahead and calculate our z-score. So we're going to take 632, sorry about that, subtract 500, press enter in your calculator before you divide so you get the correct answer. And our z-score ends up being 1.32. Now, because we're looking for a percent, and this is not a percent, we need to find the area under that curve. Okay, and this is where your chart comes into play. And if you notice, our z-score is a positive 1.32, so we're going to be using our positive z-chart. All right, so make sure you have your z-chart handy here. We're going to go ahead and draw a little bell curve here. Let's say our score is 1.32. It says who scored below Sophia, so we're looking for the left side. Okay, and remember, when you're looking for the area on the left side, you do not, I repeat, you do not need to subtract from 1. Okay, now I'm going to zoom in here. So our z-score is 1.32. Remember to use our chart correctly. We're going to first start at 1.3 and then move over to 0.02. So using my highlighting tool here, I'm going to look at 1.3, highlight that, and we're going to look at 0.2. And right here is our intersection point, which happens to represent it'll represent our probability. Now, from there, we have 0.90658. It says round to the nearest hundredth. Now, we are going to do that after we convert it to a percent because that's what we're looking for. So in a calculator, you can times it by 100 or just do a little shortcut, move the decimal over 2 places, So we have 90.658%. Your 100th spot is right there. So it would be 90.66%. That is what you would type in. All right, our very last problem we're going to go through is this one. Once again, make sure that you guys have your charts with you, your Z-score charts or tables. But let's go ahead and get rolling here. Lengths of newborn girls are normally distributed with a mean of 49.2 centimeters and a standard deviation of 1.8 centimeters. What percent, that's what we're looking for, of newborn girls will be 50 centimeters or longer? Okay, so that means 50 centimeters or above, okay, or higher. So that's important for later when we're using our table. So now let's go ahead and start with finding our Z-score. And I'm going to put that formula right in here. Our Z-score is our raw score, which is what is given, 50, minus our mean, which is 49.2, divided by our standard deviation, which is 1.8. When we plug that into the calculator, make sure you subtract first, press enter, divide by 1.8, and we end up with 0.44, and that is rounded to 2 decimal places. So now to find that area under the curve, we want 50 centimeters or longer, so we're going to be looking at the right side of that curve. Now, keep in mind, if you're looking for the right side, yes, you do need to subtract. Okay, and keep in mind that our Z-score is a positive one, so we're going to be using that positive chart here. So let's go ahead and get started. So to split that up, we're going to be looking at 0.4. So this row here, and then 0.04, this row here. I'm going to use my highlighter, maybe, if it'll cooperate with me. And our intersection point is right here. So we get 0.67003. Now remember, all of the numbers on this chart here represent the left side, the area of the left side of your Z-score. Since we want 50 or higher, we want the right side. So what we need to do, our last step is, yes, we subtract. And when we subtract, we get 0.33. And when we convert that to a percent, we get 33%. Very good. Now that you have gone through these with me, make sure you take a look at the study guide for Unit 1. Print that out. Super helpful for you when you guys tackle your unit test. Best of luck. Use those calculators, and if you have any questions, please reach out.